Hello and welcome to another Red9 demo. This one follows on from part one, which was going through the Puppet Rig, going through some of the internal features and systems within the Puppet Rig, how we bind it to metadata. I think we went through the DAG menus and the character picker, etc. This second part, what I want to do is I want to move on to the next section really of dealing with the animation itself. So this is getting animation onto, or getting raw animation and raw data onto the rig through the binder system, dealing with the browser, which is our way of batching files out, and also cleaning and filtering and redirecting your initial MoCap delivery. So this is effectively, we've had a delivery of data, we want to get it onto the rig nice and clean and get it to a point where we can then pass it onto the animator to compile the cutscene or whatever they're going to be doing on this stuff. So I'm going to introduce you to the ProPack browser. Now the browser is effectively a threaded file browser. It's as simple as that. But it's a browser with a twist, and that is that the functions that you see here are all dynamic. And that is to say, if I right click on this FBX, you'll see we have three functions available. We have some standard ones, which are these that you have no access to. These are just standard OS functions really. But these three here are bound in the extensions file. And the extensions file is a file that you can modify, you can change, you can do what you like with, and it's bound per client or per project or per team. So you can modify all the functions exposed at a team level or a game level, etc. If I click on the FBX, you'll notice we've got three things. We've got single file, multiple files, and double click. And these are the functions that we allow you to change. So single file would be, if you've got one file selected, these are the functions available. If you've got multiple FBXs, these are the functions that are available, and the double click is basically what happens when you double click in a browser, the default action. So what I want to do is I want to just show you really quickly how we can add into this and modify some of these things. So I'm going to add a new function called testing onto the FBX when we're in single selection mode, and all I'm going to do is print file. Really boring function, but imagine now that you've found an issue in the rigs, you need to patch them. You've got a quick piece of code that you've done that inspects, that does whatever it needs to do, does the patch and saves it out, but you now have 1,000 files to process. Well, you can quite easily do that, because all you have to do is, in the multiple files, write your patch, do whatever you need to do here, come back to the browser, multiple select them, right click, and it's exposed. But more importantly, it's exposed at the team level to the animators, rather than you having to manage this code side. So if I right click now on this and I open the script editor up, clear all that stuff off, and I right click, there's our function that we just added, testing, and lo and behold it's printed the file format out, or the file path out. Nothing unusual there, but it's the power within this to modify its functions. Okay, so what we'll do now is we'll show you the process of getting FBX data over to the rigging. You'll notice this thing, ProToBind. This is our main entry point for getting data over to the rig from FBX. And there's a number of different methods we've exposed for it. The first two are basically the FBX data is the same as the skeleton we have inside the binder. And the last one, HIK, is effectively the data coming in has a HIK definition, but the skeletons can be completely different. It makes no difference. It's just connecting the HIK systems together. Now, this relies on the fact you have a bind file. Now, the bind files come with the Red9 Puppet. When you work with us on a Puppet, you get a bind file. So this part is kind of tailored towards running with us as clients, if you like. The binder itself is kind of harks back to this animation binder that I did for the masterclass back in 2013, I think it was. It's kind of a similar system, but we've enhanced it with HIK. We've enhanced the way we deal with it, and we've kind of tied it all together with the rest of the systems. You'll notice here as well we've got a couple of options here and a drop down. Now this, I'm not going to dwell on it too much, but effectively this comes from this project object, and that's kind of important to realize that this is here. When you work with us as clients, basically each client has their own project database. It's not a database, it's a JSON file effectively, and all the arguments and the vars within that are exposed through this project object. There is one project object that we boot during boot up, and it's just a Python object that all the code inspects to get its various variables that it needs. So things like there is a health test when you open a mail file by default that we set, and it checks the frame rate is correct, or it checks that the target engine is correct, or we set a certain amount of things that we check, and they're all held in this. But you'll also notice here we have one for the binders. If you're running Perforce, the front of this path will also be dynamic, so it will come from your Perforce route and it mounts relative to. But we'll go through that again. I don't want to dwell, but it's just that's where these come from. And we have a number of options. So we can, by default, when we take this data across, we can choose to bake it over to the rig. We can choose to leave it on the binder active. We can generate R9 anim files. We can do it en masse. So what we can do effectively is we can take a huge chunk of FBX files, select the whole lot, click Perforce, bake to rig, save to R9 anim, and you can process all of these files and it will generate these files formats in one go. So it's transferring FBX directly to another format. We've got clients who have their exporter exposed here as well, so there's another couple of checkboxes where it will go export to, and that basically means it goes directly from the raw MoCap straight to Engine. So it's all wrapped up, you know, really nicely. In this case, I'm just going to turn these off. So this first set, these ones here are the same skeleton that we have in the binder file. So what I'll do is we'll just do a quick transfer. That'll boot it up, and it'll drop the data over to the rig. And there we go, that's that data dropped over. At the same point, what we'll have done, and again, this is something we'll go through in another video, but what it's also done is it's inspected the header data inside this FBX. It's found the start and end from the take data. It's also mapped the name across, and this is prepared as a shot node or a loop node, which is basically propagated the data from FBX into the export systems in Red9, ready to then go away and manage in an export way or as a shot way, you know, however you want to do it. Again, we'll deal with this later on. And the beauty about this is, because I've not baked that to the rig, and because we know the skeletons are compatible, I can just use this to effectively browse what these are doing and just skim through them, which is really useful. But what happens if you've got data that isn't compatible? What happens if you've just finished a project, you've got an entire library worth of animation data that's been cleaned and prepped, but it's on a completely wrong skeleton because you've now got another character or someone's, you know, you've re-rigged it. What do you do? Well, it's not really that much of an issue, because what we can do is, if I select one of these, this is a library of stuff that came from Maya, as it happens, from the examples that used to ship. I think you can download them still. And if I right click on that and go Pro to Bind, I'm going to switch this over to the Connect HIK. Again, I'm not going to do the bake because it just puts it onto the rig, and you'll see that in a minute anyway. But what I'm going to do is I'm just going to do the transfer. So let that go. Okay. So what we've got here, and close that down now, is we've got the raw data, which is the grey character, and we've got our rig. Now the skeletons are completely incompatible. They are different joint count, different joint hierarchy, joint names, etc., etc. You get the point. We'll just hide that and dance. But we're using HIK to map it over. So we've gone through the proto-bind, and all it's done is it's imported the data, found the HIK plugs, found the binder, connected the two together, and that's what's driving the rig. But it's a layered binder, and by that what I mean is that inside these you'll see we have a load of diamonds. If I deselect, we've got all these yellow diamonds inside the rig, and these diamonds are the bind points for the rig. And the beauty about this is that I can do an initial pass on this data. I could have baked this straight to the rig, but if I wanted to, for example, modify the arc of this leg, let's go from that frame, let's say, over to that frame. If I want to modify how that leg happens through that arc, if I baked it over, I'd be baking it in world space, which means I'd either have to switch it over to FK and modify it in FK, or I'd have to track that arc as it comes over in Euler space, in world space, which is, you know, quite difficult. The great thing about having it as an active binder is it's kind of a layered binder, and by that I can come in and with one curve I can modify the actual bind point. So we've got the skeleton there where it actually came from, this here that you can see there, and we've got where I've now set the leg, and that's one key, just to physically push that into a new position. And it's great for shaping because every component is bound to itself. It's not like you modify the base of the spine and the entire spine moves. You can actually shape the spine with this, which is really useful. And I've just put a couple of keys in there just to show you that we can tweak this stuff live as it goes through. I could do it with the other leg if I wanted to. I mean, the other thing with this is that I could do it to an extreme where I know I'm going to introduce IK pop, but because of the systems being soft IK, I can then just turn the soft IK to get rid of it when I've baked it out. So I've done a modification on that leg. We'll come into this. I'll just right click, bake the rig, which is, again, is a function on the DAG nodes bound to the rig. So I'll bake that off, which will get rid of our binder skeleton. Get rid of that now. So that's now baked off with the modification that we just put in. And the other thing I'll just really quickly show you, because it's really quite useful, is that we talked in the last video about the dynamic poll, about the auto solve polls. It's really obvious in this example if I zero all of those off. So I've got rid of the polls on the blue side, and obviously they are going really badly wrong. If I just set them both on, and now the polls on that right side, all the blue, is being auto solved by the rig, just to show you how it copes with complex data like that really nicely. So we've gone through showing you how to get FBX data over to the rig and pushing data onto the rig through the ProToBind system. That relies on the binder files. That's part of Puppet. So that side of stuff is kind of reliant on running the Red9 Puppet. The rest of this is anything to do with the Pro metadata, basically anything that's been connected to that node. And what I want to show you is this is a file that again has come in from MoCap. And essentially the actual raw delivery was 30 frames a second, and it's been stretched over to 60 frames and rebaked onto the rig. And as a result of that, we have lots of intermediary keys which are wrong because they were sampled at the wrong sample rate. So how do you deal with that? How would you go about cleaning this data up? Because it's really hard to do. And if we go into the curves, well, you can see the issue we've got. Now I've seen people in the past come into this, let's just select something like that. I've seen people in the past come into this and manually go away and delete keys, which is well, it's a thankless task, let's face it. So what we're going to do is we're going to open up the curve editor. This we've shown, there's a demo of going through this and using it as a sampler, but you can also do to get rid of stuff like this. So what I'm going to do is, we know we're at 60 frames a second, we know the data was 30 frames a second. So what I'm going to do is I'm going to select some of this data. I've already toggled the curves and buffered, and what we'll do is we'll just get rid of that, and it's got rid of the whole lot. Now I did that on one object, so let's do that on the entire system. Let's select the whole character, come back into this 31 process. Obviously it's going to take a little bit of time because we're dealing with 1600 frames, not too bad. And then the other thing I'm going to do is when I'm in there, go back to the graph editor, is I should just run a quick Euler on all of that lot because I suspect we might need it. Curves, bosh, there we go. And that's cleaned it. So that's using the Butterworth filter to basically resample and to modify and clean up some of this data. And as we've done this, we've come to this, if we actually get to some of this point, you see there's a lot of noise in this. This is quite old MoCap data, particularly when he does this. Let's show you this bit, because this is really where this stuff comes in. So if we look at the curves on these, bear in mind that last one really didn't actually do any sampling, it was just a way of getting rid of that initial data. But there's a lot of noise in these polls. And if I show you this, let's go to where he starts it. Here we go, just there. There's all sorts of noise on that. And again, getting rid of that, is a thankless task. So we can just come into this stuff, and maybe we could do it, aggressively over the whole thing, or we could do it just over a little part of it. And we can maybe say, well, actually, I'll do it on a sample width of 3, process that section. And then fairly solid. And we can do that over the whole thing, we can literally just grab that and we can run a clean pass over everything in the rig just to get rid of some of the noise if we really needed to, if we were struggling with noise in data. So again, that's another really useful tool for cleaning up, getting rid of noise and dealing with the curves. And then the last thing that I want to show on this one is, we've dealt with the MoCap, we've loaded it and we've cleaned it and we've got rid of any noise that we might happen to have. But what happens, and this happens all the time in MoCap, is you do the best planning you can. Maybe you take along dimensions of the room, where the tables are, where the doors are, and you MoCap it all to that. You get back to the office and the environment artist has changed the position of the door and you've shot all this MoCap data. How the hell do you deal with that? Again, this is kind of the initial steps before it goes over to the animators to do their final passes, etc. So what I'm going to do is we will load a sequence up, which you've probably seen before. If I load the demos, redirector. This is quite important as well. The R9 anim file recently went through a bit of a makeover and it's now really, really fast. So this is 1300 frames long of dense baked MoCap data. I'm just going to select that rig and load. If you watch this isn't sped up, this is just it loading. Okay, where are we? 90, 100% done. So that's got really quick. Okay, so what I wanted to show was, again, just a really quick one on this, is that let's say he's walking around and he's very carefully being done, so he walks through a door that's just there. So let's stick a door in. Stick there, move it across, somewhere around there, scale it down. Okay, that looks about right, doesn't it? Maybe scale it a bit, just so you can see. Okay, so he should go through that door aperture, except he's not, because what's happened is that the environment artist has decided the door is now there. So again, how do you deal with that in a fast, fluid way? So we'll boot up the tool in the arsenal, which is this thing, the Anim Redirector. And I'll do it over a little part of this data because there's no point doing it over the whole lot. There's a lot of data to process here. So we'll start somewhere around there. What I'm going to do is I'll select a point on the character, which is kind of going to be used as a tracking route. Turn everything on. There are plenty of videos of this, so I'm not going to go through again. This is just like an overview. I'm going to set the time because I'm going to do it from, I'm going to redirect from maybe there through to the point where he's meant to be going through the door, there. Set time range. I'm going to build the guides. I'm going to do a fractional knots, sync the cloud. This just pushes the cache over to the systems. 552. Okay, that's done that. So what we've now got is a cache of the data doing it, and that's where it currently is. And what I'm going to do is we'll lock the start of that, which basically locks this start in place. So when you're moving these, you're directing these as a group, if you like. And I'm just going to go away and say, you know what, I actually want him. He's going to carry on walking, but I'm going to just move that over there. I can redirect. Maybe just move that as well. Let's say, getting there. Bit of that. That'll do. Let's straighten him up a little bit as well. Just something like that. Okay. So we've taken the initial curve, we've modified it, so we've changed its trajectory, and we're just going to apply that data. So again, this is kind of a first pass of what you do to get the data to a point where you can pass it to one of the animators and let them get on with constructing the rest of the scene. This is dealing with the data as it is in raw terms. So it's just redirecting it, and we're done. So if I delete the guides now, what he was doing was walking over here. What he's now going to do is he's going to walk through this new door because we've told him to. And you can see it's rock solid. And he's going to go through the new door. Obviously there's a pop there where it dropped off the frame. We went up to 552, I think we did. Yeah, there we go. But that's the difference. And again, that's taken me, what, a minute to do that. With a bit of care and attention, you know, you can get that really spot on. And obviously dealing with foot slide is dead easy because you just use the foot fitter, or rather the snap transform, I should say, which would be this thing here, just to stabilise. And that's it for this part. What I'm going to go through next is how data propagates through the Red9. So we've showed you FBX over to the rig. We've shown you that already makes an export loop, or rather a shot loop, which propagates the data over to that. The next one we're going to show you is the data that's stored inside the R9 Anim, the data that's stored inside the export systems, how all that data fits together, including audio, and how you can use that to manage things in a more fluid way. Thanks for watching. I hope that was useful. Thanks, bye.